Welcome to Dilip Tipugade Sir only mathematics channel. Today we can be see in a real number. That question will be, show that root 2 is a irrational number. Root 2 is irrational number. We can be prove here root 2 is irrational number. We can be take here indirect proof. Root 2 is irrational number can be shown here, but indirect proof. Let us assume that we can be assume here root 2 is a rational number. Root 2 is a rational number. We can be assume here. Then if root 2 is a rational number, then any rational number or each rational number we can be write P upon Q form. Root 2 will be equal to P upon Q such that P upon Q is a rational number. P and Q have no common factor except 1. There is no any common factor between P and Q. Because of we can be assume here root 2 is a rational number. Here P upon Q is a rational number and P and Q have no any common factor except 1. We can be assume this. Then squaring both sides we get root 2 equal to P upon Q. Then squaring both sides, root 2 square, that will be equal to 2. P square upon Q, that will be Q square. P square upon Q square. Then cross multiplication will be here. 2 multiply Q square, that will be 2Q square. And P square will be here as it is. This is equation number 1. This is equation number 1. And in this case, we can be say here P square is a one number. P square is one number because of 2 multiply Q square. 2 multiply any number. Then this number is obviously a one number. P square is a one number. And we know that here if P square is 1, then its square root will be also a one number. Then P is also U1 means 2 is a factor of P. Because of 2 is a factor of P, then we know that here P is also a one number. P is also a one number. We can be write P equal to 2T. Suppose T belongs to I. We can be take here T another number such that 2 times T, because of P is a even number, P will be equal to 2 multiply T, 2T, because, or we can be take here T belongs to I. T belongs to I. Squaring both sides here, squaring both sides, we get P square, 2T square, that will be 4T square, 2 square will be 4 and T square will be as it is T square. Then cross multiply here. Then from 1 we get here, from 1 we know that here 2Q square equal to P square. 2Q square equal to P square. Put value of 2Q square instead of P square. Put value of P square, that will be 2Q square will be equal to 4T square. 4T square. From 1 we get here. Instead of P square, we can write here 2Q square. And 4T square will be as it is. Then Q square equal to 2T square. Divide by 2 here. Divide 2 here. Then we get here Q square equal to 2T square. Q square equal to 2T square. In this case also, Q square is a one number. Q square is a one number because of Q square will be equal to 2 multiply T square. And Q is also a one number. q square is 1 because of q square equal to 2 multiply t square, and its square root also u1. Q is a u1 number. 2 is a factor of q. 2 is a factor of q. From 1 and 2 here, we know that here p is also u1 number and q is also u1 number. Then 2 is a factor of p and q both. 2 is a factor of p and q both, but this is a contradictory. This sentence will be a contradict sentence because we can be assumed that p and q has no common factor except 1. But in this case here, 2 is a factor of p and 2 is a factor of q also. This is contradictory because of p upon q. P upon q, 2 is a factor of both. And this is a contradict sentence. We have to be assumed that p and q have no common factor except 1. We can be assumed that here p and q has no common factor except 1. Our assumption is wrong. Hence, our assumption is wrong. Hence, root 2 is a irrational number. Hence, root 2 is a irrational number. This will be a proof of root 2 is a irrational number. Our assumption will be wrong. Hence, root 2 is a irrational number. Irrational numbers. A number whose decimal expansion is a non-terminating, non-recurring. Non-terminating, non-recurring is irrational number. Irrational number, a number whose decimal expansion is non-terminating and non-recurring. For example, we can be say here root 2, root 3 are irrational numbers. Similarly, 1.23, 233, 2333 and so on. This type of number is a non-terminating one as well as non-recurring. Hence, those numbers are irrational numbers. Those numbers are irrational numbers. Similarly, we can be say here a real number. We know that here real number set denoted by letter R, capital R. A set of rational and irrational numbers are called as real numbers. Set of all rational and irrational numbers are called as a real number set. For example, 2, 3 upon 4, root 2, root 3. 2 is a rational number, 3 upon 4 is a rational number, root 2, root 3 are irrational numbers. Set of all rational and irrational numbers are called as a real number set, and those are the real numbers. But we can be say here root of minus 2, not here minus 2. Root of minus 2 is not an irrational number. This number is not irrational number because of in a root there will be minus sign, and this is a not irrational number as well as we can be say here this is not a real number also. This is not a real number also because this is not a irrational number. If you have liked this video, like and subscribe the channel. Share another students also. Thank you very much.